Welcome back to episode 24. We are picking up right where we left off with the Shai-Hulud lander on its descent into the upper atmosphere of Duna. Now, if you remember, there are no solar panels on this, and there is also no antenna. So we do have just enough connection through the onboard uh, probe core's antenna to, get full control for the actual landing, but we won't be able to transmit anything. And any electric charge that we actually use is going to be gone forever. We won't be able to get any of it back. Which is a pretty big foresight on my part. I remember putting antennas and solar panels on this, but I could have just completely hallucinated and forgotten about that. But regardless, we have to land this thing. So, descending now through the atmosphere, and you can see my speed is just starting to slow down. And so I fire up the engines. We still have several hundred meters per second of delta V in this stage, and I plan to use as much of it as I can. So we're just going to use that to arrest our descent and, pick out a nice landing spot. And this should be good enough. That giant heat shield is basically useless at this point. It's really just going to be there for providing drag. We're going slow enough, and Duna's atmosphere is thin enough that we won't really get anything useful or any useful heat protection out of it. There's not going to be a whole lot of heating anyways. So we have some, I'm just looking at all my batteries here, and there are no solar panels hidden away, stowed inside something, which is, yeah, at this point, I think I was just in denial mostly. So we also have these 3 engines and more than enough fuel, I think, to give us a powered landing. You can see it's about 340 meters per second, and we are going much faster than that, but we're slowing down at about half a G. And we've still got a lot of atmosphere below us. I mean, there's not a lot of atmosphere, but there's most of the air, thin, tenuous air here is below us, and we've got some slowing down to do. So mostly just coasting down. Once we get into flying low over Duna, then we'll be able to perform a little bit more science. I'm saving that mystery bay, the Science Junior Mystery Bay, for once we've actually landed on Duna. Although we won't actually be able to transmit any of the data back. So just monitoring all my parachutes, making sure they deploy high enough from the surface that I'll actually have enough of a chance to let them slow me down all the way. And we're now in a regime where we have actually enough fuel to slow down without the parachutes, of which only one comes out because of the pressure. So I have to go into the settings and reduce the deploy pressure. And out it comes there. And that third one as well. Just making sure they all deploy at the same altitude, which I have arbitrarily chosen as 3,800 meters above the surface of Duna. And that way I'll have symmetrical deployment and I won't be coming down too unevenly or anything crazy like that. And we can jettison the heat shield. It's done its job. And yeah, we've got those 3 engines there. We can deploy the landing legs to help cushion our impact. And yeah, at this point, we're flying low, so I should be able to do some more experiments, although I do want to make sure and get a little more control of my descent before that happens. Just a touch of the throttle here, bringing our speed down so we have a nice parachute deployment. And in a moment they will open. And we're just coasting down now. And there they go. Slowing us down way more than I was anticipating. That is surprising. Normally it's very hard to land on Duna with just parachutes. The atmosphere is too thin that they don't actually do a whole lot for you. I'm just doing some science now, but this has slowed us to 7 meters per second, and I was expecting them to get us to maybe 20. So this has been either something is up with Ferrum, or that's just how it is with a very, very light lander and 3 of the large parachutes. And so now we just descend the rest of the way until we're just a few hundred meters above the surface, at which point we can, we'll just use the engines to kill off that last bit of speed just before we touch down. And let's point retrograde, and now touchdown. 4 meter per second landing. So now we can perform the rest of the experiments. Let's start with this. Let's start with the thermometer. Log the temperature. Duna is colder than you expected. Although Mars can get up to 70 degrees in the summer. Strong winds from a passing dust devil will do something to the goo. Collect, log, where is it? Let's monitor that. Log seismic data. Gives insight into the seismic activity of Duna. And the barometer. There isn't much atmosphere here. You consider lighting candles to create more. And now the Science Junior. Opening up there. Samples are slowly turning red, or is that just your eyesight? I would actually consider it to be more of a kind of brownish orange. Now we can deploy this drill. This is from the Interstellar pack. Just gives us a little more science. We can collect a surface sample. Extract. There appear to be traces of water in the soil. Of course, a reference to how there is ice just beneath the soil of Mars, or the regolith of Mars. And that is the end of this mission. I'm just checking through my settings here and making sure that just confirming my worst fears that there is no way to transmit any of the science on this vessel. And basically that is just going to sit here for essentially forever. So we put it in hibernation, and we can instead wait for a future mission when some crew can come here to take the science and bring it home. Lots of records that we've set, which will give us some money and a tiny amount of science. But the actual data recovered from this mission will have to be retrieved by Kerbals who come visit Duna at some point in the future. Which I have no plans for as of yet, but we will just have to see, and until then, we will be stranded here in this red wasteland. And with all that money, we can upgrade our research and development all the way to the highest level, which allows us to research even more technologies. This is now, we're really starting to get into where interstellar parts are coming into play. So beamed power, mostly, as well as a lot of B9 parts, more advanced robotics parts and reactors, as well as photon sail upgrades, very large fuel tanks, and ion engines, which I definitely want, more advanced nuclear engines and fuel systems, bigger engines, and this giant molten salt reactor. I'm going to get that, and I can unlock 2 more nodes, and we just pick some other things. Now, we have our second sun skimmer here. The first one, if you remember, was just a few hundred kilometers away from the near science boundary of the sun, but did not cross it. So it was basically useless. But this one I plan to take all the way close to the sun and perform a sample return. So that way we can get the full science payback of all of the full science rewards of all of the experiments that we're bringing, as well as, we've got much more science equipment on this than we did with the first sun skimmer, so we expect some pretty big returns from this. Launching on an SRB, and I've chosen a launch time such that I can basically just point sideways once I'm in space, and burn up all of my fuel, and we should be pretty well positioned to go to the sun. Now I'm launching into an orbit here because that is the most efficient. You get more returns out of your engines when you are not fighting gravity, going straight up, and when you are also close to the planet the whole time you are doing the burn. So I'm just figuring out what I need to do here, and I determine I actually need to go all the way into orbit for this to work. So we deploy the solar panels and the antenna on the probe there, and wait until we reach apoapsis. We can do some science with this gravity scan from above Kerbin. And you can see we've got a lot of delta V in here. There is an ion engine on that upper stage there, which for some reason is not showing its delta V in the readout there. And also not in Kerbal Engineer. So I suspect there are some bugs at play here. But then we can actually plot out our maneuver. I figure I plot this maneuver to be with all of the fuel left in this chemical stage. We execute that. And we just burn through all of the fuel in this stage. And that gets us within the orbit of Moho, though still not close enough, so we will have to make the rest of the distance with that ion engine, which we activate. Now, ion engines are they are engines for the patient. They work by having some kind of neutral gas, usually xenon, or some noble gas like xenon is the most common one, but you can also do it with argon and other things. You ionize it, so you strip the electrons off of them and separate them. And then you use an electric or magnetic field, depending on which flavor of which ion thruster you're using. You can use electrode plates, or you can use the Hall effect, which has to do with magnetic fields. And you use that to accelerate the ions to extremely high speeds, where chemical propellants typically are in 5 to 10 kilometers per second. These can get up to hundreds of kilometers per second exhaust velocity. Now, because they are very lightweight ions and they are going through very slowly, and then, of course, once they exit, you spray the electrons into the exhaust, so that way you neutralize your ions so they don't come back and stick to you and remove all the thrust. But they have very low thrust, but extremely high specific impulse, in the thousands of seconds, a lot of them are, which makes them require lots of patience to use. This burn here took about... well, you can see there the burn time is 2 days, which is, and that's not just the time to node, that is the actual length and duration of the burn. So I've put this on 12 times speed thanks to better time warp. But yeah, ion engines, the way you use them is basically just this. You let them on for a very, very long period of time. Very little thrust, but over extremely long durations that can build up into lots of speed with the efficiency that they have. And yeah, they've been in development since the 50s, around the same time as chemical rockets really started to take off, both figuratively and literally. But they've only really started to become used a few decades after, and very much ubiquitously in the modern day. While we're out over the sun, we can take some more science, transmit everything back that we can. We have a utilitron observer here, which gives us EVA reports without a Kerbal. And we just finish up the rest of the burn, bring our solar periapsis just within the boundary. And that should be good. So we set the alarm. And then I also have to plot a maneuver to return us to Kerbin. Which, there we go. And we'll come back to that in the future. Now this preposterously large vehicle, which is just barely clipping through that 5-meter fairing there, which is the largest I could make it. This is the next module of our Eve vehicle. And it is, well, it's big, which is why I'm launching it with all of these things here. You can see in the upper left, it's running. I've sped up this footage 4 times, and you can see this is how fast it was actually going. You can see this time is ticking by, now a bit quicker since I'm in the map view. And we're just getting ourselves on a trajectory that intersects, getting ourselves prepared for a rendezvous. This is kind of slow and lumbering, which is why I will be a bit more delicate with these maneuvers. That 3.75 meter core on the first stage there, surrounded by those boosters that I am ditching with asparagus staging, that is 4 engines strapped together. Those are 4 1.25 meter engines from KW. And they were workhorses very early on in the space program, if you remember those ones modeled on the Titan, I believe. And they're coming back now to, well, help us get into space. This ginormous vehicle. So just burning into orbit. The drive section, the fuel and the drive section are moving ahead of us, so we'll have to put ourselves into a bit of a lower orbit than it. But in the meantime, I guess I can explain what is going in these fairings. So this is going to be kind of the crew section. I've got some atmosphere probes and a ghillie lander. So of course we have, you know, the labs and the science experiments and all of the space that the Kerbals will need. And now we ditch that. Well, this thing really just looks like an egg now with just that fairing there. Flying egg into space. Barely managing over a G of thrust, but it should be enough at this altitude. And at the speed we're going, we should be able to build that up pretty quickly and get into orbit. And once we ditch that fairing, that will give us a lot of weight. The loss of weight should help us out a good bit. And we're just going to get up to that altitude where the fairings will auto-deploy. Unless I forgot to configure that, although I doubt that I did. Yeah, there we go. You can really see what this thing is going to look like there. Admire the symmetrical star pattern that the fairings deployed into. So yeah, you can see down the middle we've got a crew section and the lab module. On the top there is a lander, which has all of the science, and it's mostly just a monopropellant and small liquid fuel engine powered lander. Nothing too fancy there. On the side, though, we have 2 atmosphere probes, and I'm going to send both of those into Eve. And they're going to return science, one of them from the upper atmosphere and where it lands, and one from the lower atmosphere and where it lands. I've got some radiators on the side as well to manage the thermals that we produce. Keep all of that in check, because we do have a nuclear engine on that drive section, and we don't want it to overheat. We want to keep our cryogenic fuel cold. And I skip out the entire rendezvous because it's very boring. So we are now lined up, getting our speed managed, and I'm making sure my alignment is good so that none of the pieces are overlapping with each other. I'm docking this onto the fuel section right now, which if you have eagle eyes, you may notice that leaves no free docking ports. So the crew section, where with the capsule return vehicle, I'm going to launch that separately with the crew on board, and it's going to go in between these 2 sections here, between the fuel and between this lab and probe and lander section. I'm just docking them now because, well, I want to get this part into orbit independently, because it's very large and it'd be difficult to launch it with crew. And also so that it's, you know, I don't have to do a bunch of rendezvous back to back, and I can instead just undock this when the crew arrive and redock it with them. And now we deploy the solar panels, keep this thing powered, set up everything, the antennas and all of that, and we can, we really start to see how this thing's taking shape, and we'll be ready to depart for Eve within the next couple of weeks once the window is actually here. And yeah, it's quite a beautiful vessel I've created here. I'm rather proud of it. And there we have it. Crew will come soon. Now, in another preposterously large fairing, this is not the crew of 3 who we will send to Eve. This crew of 3, Munpont, Erlin, and Jarek, are going to the moon, and they're going on a very special mission. This lumberingly slow vehicle, which again, this is 4 times footage, but because of the nature of this vehicle, it is running, 4 times speed has basically brought it up to normal speed, as you can see in the clock in the upper left. We're going to put this on the moon. I've named it Challenger Base, not after the space shuttle, but after the lander of the Apollo 17 mission, the last and longest mission. Taking some inspiration from that, although we will stay there a bit longer. Apollo 17 stayed on the moon for about 3 days. We have enough life support for a crew of 3 to stay about 9 years. Although I doubt their mission is going to last that long. So my plan with this is basically to land it on the moon, do a bunch of science wherever we go, explore all the biomes, explore the anomalies we've detected with the scanning satellites. And once that is done, they can come home in a separate vehicle. But there's some fancy tricks that I have up my sleeve that you'll see once the fairing deploys. So now the SRBs go. And just to give you an idea of how much this thing weighs. When those engines light up on a full tank, we got a thrust to weight of about 1.5, which is not bad. But those 4 engines are a mainsail surrounded by 3 skippers. So this is a very hefty vehicle. And we're just launching this into orbit. A good ascent, a bit steep, but honestly I would not want to go too shallow with this thing, and I want to have as much margin for error as I can because there are no heat shields and no parachutes on this. I believe the crew have their own personal parachutes, but this was a very expensive vehicle and it would be a shame if all of that went to waste. I want to get the full use out of this. So once they are in orbit, they will plot a course for the moon, and then we'll land there and we can begin our operations. And yeah, this will basically be a base, given how large and complex of an actual vehicle it is, but it will be a mobile base, one that can fly around and pick its landing site with some liberty. So once this stage burns out, we have another one with about 2 kilometers per second of delta V. That should get us the rest of the way into orbit, and then on a trajectory to the moon, and probably help us with the landing a little bit too. So now you can see kind of what this looks like. In the center there, we've got a lab from the Interstellar pack and the command module, which seats 2. The total capacity is 4, and we've got a crew of 3, so it's a little bit cramped, but they'll be fine. And on one side, we have a bunch of life support and some science equipment. That's the side on the bottom there. And on the other side, we have the drills and our newly unlocked ISRU refineries. There's a bunch of different ISRU and a bunch of different resources, and I suspect they are not all from Interstellar mod either, which is not helpful at all. But this one is just a pretty capable one. It converts ore into liquid fuel oxidizer and monopropellant. It can also purify water, which I doubt we'll need given the 9 years of life support. But we'll be able to, the base itself should have about 550 meters per second, you can see there. And that should be enough for us to fly around with pretty good range and land in some different biomes. And then we'll be able to drill some ore, refine it into fuel, and fly around to the next landing site. Which should be able to last us basically indefinitely. Although we are on a fairly long episode, just over 22 minutes. So once this thing gets in orbit and we have plotted our course to leave for the moon, well, we're going to have to call it here. We'll see how this thing performs in next episodes, how this arrives at the moon, our landing and our operations. But that will be the next episode. Until next time.